Hey everyone, this is Dr. Walker. This is video 249. We're going to go over right hand rule number 1. So this is the first of 3 right hand rules that we're going to learn. So the purpose of this right hand rule is to find the direction of the force on a charge moving in an external magnetic field. We just learned in the previous video that a moving charge in an external magnetic field experiences a force. So in which direction is that force? We learned that the force was perpendicular to the plane containing V and B, but that still didn't give us quite enough information. So here's right hand rule number 1. First of all, you have to use your right hand. So remember that you're kind of looking at a mirror here, that this is my right hand. You're going to want to point your fingers in the direction of the velocity. So which way is the charge moving? So let's say that the charge is moving to the left. So I would point my fingers to the left. So that's my left here. And then fold or curl your fingers in the direction of the magnetic field. So let's say that this charge is moving to the left, that it's in a magnetic field that is going down. So you would fold down. Now I learned to go down like this, just fold like this. But some people learn to curl, and then instead of the fingers pointing down, it would be like this part of the fingers pointing down. So whatever you prefer. The picture I have on the slide shows curling, but I just learned just folding. And once you have folded your fingers in the direction of the field, then your thumb is going to point in the direction of the force. So in this case, the thumb is pointing towards me. So that means that we would say that the direction of the force is towards me, or if this is the page, right, this screen here, that's the page, we would say the force is coming out of the page. So we're going to do 3 examples so that you can really practice the right hand rule. Oh, before we do that, note that this rule is only valid for positive charges. Always use your right hand. It only applies to a positive charge. If the problem is dealing with a negative charge, that's okay. Still use your right hand, but then whatever your answer is for the direction of the force, then it's going to be in the opposite direction for a negative charge. But you still always want to use your right hand, otherwise you're going to mess things up. Okay, let's look at the first example. What is the direction of the force on the proton? So let's talk through it just a little bit before you practice it on your own. What the picture is showing is that the velocity is up, and look at which way the magnetic field is. Magnetic field points from North Pole to South Pole. So at the location of the charge, the magnetic field is to the left. So that's really important to see. Magnetic field is to the left. So with that in mind, use the right hand rule. Point your fingers in the direction of V, and then fold in the direction of B, and your thumb will be in the direction of F. So give it a try. Now let's do it together. V is up, and then you're going to fold to the left. So this is my left. I'm folding to my left. My thumb points towards me. So that means that the force is coming out of the page. Again, when you're doing this in front of you, it's like the screen is vertically in front of you. So the force, the thumb is coming out of the screen. Now, what if when you had put your fingers up, what if you had put them like this, right? Then how do you fold your fingers to the left? You can't, right? You can only fold out of the page. So when you first put your fingers in the direction of V, and then when you have to fold in the direction of B, you might have to rotate your hand so that you can fold in the correct direction. Keep that in mind as we do the second practice. So this one says that there's an electron beam, but it's just showing an electron here, passing between the poles of a magnet. Which way is it going to be deflected? So we're looking once again for the direction of the force. We know that we need V and B in order to find F using our thumb. So try it on your own. Pause the video Now let's take a look. V is going down, and then the magnetic field always points towards from the north to the south pole. So B is to the right. Always use your right hand. Doesn't matter if it's a positive or negative charge. We want to point our fingers down. Okay, so sometimes you have to twist your hand a little bit. Okay, it's kind of hard to put it straight down here with the microphone, but that's pretty far down. Now, if I put it down like this, then I can fold to the right. So this is my right. I'm folding to the right. Which way is my thumb going? It's once again coming towards me. That means out of the page. Again, page right here, right? The thumb is coming out of the page. This would be into the page, right? This way. So, the thumb is coming out of the page. Remember the notation for out of the page? It's a dot. So the force is out of the page. However, the right hand rule is for a positive charge, right? We said if we're looking at a negative charge, that means that the force is in the opposite direction. So the force is actually into the page for the negative charge. So the answer is D, into the page. So you see these take a lot of practice. So for the third one, really practice it on your own before watching me do it, because you're going to want to practice these over and over until you get really comfortable with that right hand rule. So, this last one here says a beam of positively charged particles passes between the poles of a magnet. And this time it gives us the force. It wants to know the field. And V is into the figure. So, into the page. So, what this means is you're still going to use the right hand rule. You're going to have V into the page. And then you're going to have to figure out which way do you need to fold your fingers, because that's the direction of B. Which way do you have to fold your fingers so that your thumb will point upward? So, as far as the way the answers are, if the magnet's north pole is on the left, then that means that the field would be going to the right. That would be the first answer, the field going to the right. If the magnetic pole is on the right, that means the field is going to the left. So instead of looking at these answer choices, we can just say, okay, if the field is to the right, that's A. If the field is to the left, that's B. So try this one on your own. Now let's do it together. V is going into the page. So into the page. Remember, my page is right in front of me here. I'm going into the page. And now, which way can I fold my fingers so that my thumb is up? Well, I happen to put my hand just the right way, because when I fold to the left, you see that my thumb is up. That's exactly the way that we want it to be. So that means that the magnetic field goes to the left. So that's answer choice B. So if I had put my fingers this way, for example, with V into the page, well, if I had folded to the right, this is my right here, then the force would be down. So you can see the difference. Folding to the left, force is up. Folding to the right, force is down. But we wanted folding to the left. So there will be plenty more practice with the right hand rule. One more thing. Most people are right-handed, not me, but most people are. So if you're taking a test and you're right-handed, make sure to take your pencil out of your hand so that you can use the right hand rule. Because often I see right-handed people try to use their left hand because their right hand has a pencil in it. So just keep that in mind when you use the right hand rule.